Hey everybody, welcome to our webinar today, Combined Water and Space Heating Combi Heat Pumps. I'm Joe Wachunas with Electrify Now, here as always with Brian Stewart, and we'll introduce our great panelist, Jane, in just a second. Today's webinar is being brought to you, of course, by Electrify Now. We're an all-volunteer organization promoting electrification as the quickest path to decarbonization, and something that we can all take part in achieving. And the LEARN program, which is a San Diego-based workforce education and training program that's partnered with us at Electrify Now to offer these free energy efficiency and electrification webinars. Please visit the LEARN website for more information, www.sanDiegoLearn.com. And this webinar is part of our Go Electric series. The last year plus, we've been looking at all the benefits of electrification from homeowners, which of course include lower energy bills in most parts of the country, cleaner indoor air and less pollution outside, more comfort, and increased safety. And today we are going to be talking about Combi heat pumps. Now, this is a heat pump that heats both air and water and also provides cooling all in one system. One heat pump to rule them all, you might say. But how does a Combi heat pump work? We're going to be looking into that. And what's the difference between these air-to-water heat pumps and the air source heat pumps, the ductless heat pumps and ducted heat pumps that we talk about a lot at Electrify Now? What are the advantages of Combi heat pumps? How do you get one installed, and how much does it cost? And are there any benefits, other benefits, like to the electric grid with Combi heat pumps? And what are challenges that folks should know as they're considering purchasing one?
All right, well, thanks, Joe. Today we're going to get into the, all the details on these systems, and I want to start out with just a little kind of maybe a little bit of an oversimplification, just to kind of give people some context on how these systems are set up and what some of the terminology that we'll be using later in the program. But there's kind of two basic types of systems you hear. They're either referred to as monoblock systems or split systems. A monoblock system, the basic components is it's got an air source heat pump external, which is going to look pretty much just like a regular air source heat pump, but they're typically a little bit larger than a air to refrigerant product. And the reason for that is because it's just like an air source heat pump, harvesting energy from the air, and there's refrigerant in that unit. But there's also a heat exchanger where the heat that's captured in the refrigerant is exchanged to water. And then it's water pipes that are connected to your home. So there's only refrigerant in that external unit. And then water pipes that are usually have glycol in them to keep them from freezing go into the house. And then the other components, there's going to be a controller that's, with pumps and valves that's, determining where that water goes. But there's always going to be a water tank where that hot water, if you're in heating mode, is stored. And obviously we're using that water for domestic hot water as well. But then that hot water or cold water can be used for space heating, either in radiant systems. You might have underfloor radiant heating, or radiators on the wall, or forced air systems that look essentially just like the ones that we're used to with air source heat pumps, but they're hydronic, they're water-based. So inside your home, all there are water pipes, no refrigerant pipes inside your lines inside your home. And then a split system is very similar, but the difference is that it's called a split system because this heat exchanger that we were talking about, that goes from where the heat from the refrigerant or the cooling from the refrigerant, either way, is exchanged with water, that is inside the house. So you've got refrigerant lines that will go to what's often referred to as a hydro box. It's basically a heat exchanger inside the home. It also has those control valves and things we were talking about. Sometimes that hydro box is actually connected to the water tank. Some systems are configured that way, but then the rest of the components are basically the same. You've got a water tank for storage of energy, but also for domestic hot water. And then you've got these various kinds of distribution systems for distributing the heat and the cooling throughout the house. So some manufacturers choose to make only one style of these. Some make both, and we'll talk a little bit more about that as well in a minute. Okay, so just to give you a sense of what the stuff looks like, like I mentioned, there's going to be this heat pump that's external to the house. They look pretty much just like regular air source heat pumps. Like I said, they tend to be a little bit larger if they're monoblock systems because of that heat exchanger that's inside the external unit. Inside there will be a controller, and you'll see the harvest control harvest. Our panelists today will talk more about this in a minute, but other manufacturers also have these controllers, or the hydro box that I mentioned might have the control valves and things inside of it. And then of course there's the water tank that looks, generally speaking, it was going to look like a hot water heater, but some of them look a little bit different because they've got the hydro box associated with them, like this Ecodan system here down at the bottom. And then in terms of distributing the heat, there's devices that will look just like the ductless mini splits. They're hydronic. They're using water to convey the energy to the wall-mounted unit, or you'll see wall-mounted radiators that are pretty much just like the old radiators that we used to see in our old schools and some of our old homes, but they typically are more efficient because they've got small fans in them oftentimes to help move the energy. Underfloor radiant heating, like we mentioned, and then there's also air handlers that look basically just like a air handler that we're used to, that replaces your furnace that's connected to your ducts in your home. If you've got ducts in your home, is blowing hot air or cool air through your home, and again is using water to convey that energy. That's the difference. These are all water-based systems. All right, so what are the advantages, the benefits of a Combi heat pump system? Well, like any heat pump, they're going to have lower emissions than fossil gas. And we'll get into, there's some ways that you can tweak these with the thermal battery that we're going to be talking about to make them even more efficient. But essentially, they're going to dramatically reduce carbon emissions because they're so much more efficient and they're not using fossil gas for heating. This thermal water tank is a really interesting component that different brands use in different ways. We'll hear again about that from our panelists today, but it has the potential to really increase the efficiency of the system and lower the costs. These monoblock systems where the refrigerant is only in the external unit have some other advantages because they typically use very small amounts of refrigerant. And because they're outside the home, there's different legalities about what kind of refrigerants can be used. And so you can use low global warming potential materials like propane or carbon dioxide. So they're potential advantages from a refrigerant standpoint. And then from a water heating standpoint, these systems can be more flexible. You know, there's some, I think we all are familiar with heat pump water heaters, and there are some places where heat pump water heaters they're tough to fit into your existing home. There's some potential for more flexibility with your water heating system, and typically a faster recovery times than even a heat pump water heater, which already are pretty good. And then there's also some potential, we'll explore this more with our panelists, that that you can have lower impacts on your electrical panel. I think this is really going to depend system to system, but there is a potential for this because instead of, you know, a heat pump water heater, which needs a big circuit, and a heat pump that needs a big circuit, you might be able to get away with fewer circuits on your electrical panel. Okay, so who's making these? Of course, we're going to talk to Harvest in just a moment, but there are other brands that are doing this and that are either based here in North America or have been building these systems and delivering them in Europe, where they've been popular for many years, and to some degree in Asia as well. They're just starting to get to the United States. So Daikin, Samsung, Mitsubishi all offer systems in Europe. Daikin and Samsung are starting to offer them here in North America. Mitsubishi doesn't have plans to do that yet, but that will probably change as this market develops. It's still a relatively small market in North America, but it's a really exciting one. And there's lots of places where there are already water-based heating systems are installed. And so this can be a really interesting way to transition some of the boiler-based systems to much more efficient heating. But there's also, like I said, these other benefits that make it attractive for almost any home in North America. We'll talk more about, you know, how you could find a contractor to install a system in your home. But this is there are other brands out there, but these are some of the main ones that you will come across in North America. All right, so with that, let's introduce our panelists. We're really excited to have Jane Melia, PhD, who's the CEO and founder of Harvest, with us today. Harvest is doing some really interesting things in this space that you'll hear about. Jane co-founded Harvest, which designs and produces the Harvest system. It's an all-in-one heat, hot water, and air conditioning system with thermal storage, and we'll hear a lot about that because that's one of the really exciting things about their system. Jane has got pretty much every accolade you would want or degree you would want in terms of someone who really knows their stuff when it comes to water-based systems. She's got a Cambridge PhD in fluid dynamics. She's a civil engineer, and she's a transformational business leader. She's a mother of 3 and a low-key, she calls herself a low-key climate warrior. I don't know, low-key, I love that, but she's a climate warrior for sure with 15 years of startup leadership in this space. So really excited to have Jane with us today. Welcome, Jane, and I'm going to turn it over to you. And while we're doing that, I just want to remind our audience if you've got questions, please put them in the Q&A, and we will do our best to answer those as we go through the presentation and the Q&A session after. So Jane, thank you for being here and welcome.
Well, thank you very much, Brian and Joe as well for the introduction, and I'm looking forward to a good conversation here. So you should be able to see my screen. Can you confirm?
Yes.
Absolutely. Okay. Well, hello, everybody. So I'm Jane, the CEO and co-founder of Harvest. And what is Harvest? So it's a combined heating and hot water system that also includes thermal storage. And I'm going to dig a bit more detail to that in a few minutes. But suffice it to say, this allows us to reduce both the bills and emissions more than standard non-Combi heat pumps. And it's one of the exciting new and scalable ways that of making heat pumps better and bringing more heat pumps into and clean electric solutions into as many homes as possible. Now, a quick introduction, as you mentioned before, Brian. So I'm CEO and co-founder. I'm a civil engineer. And I'm passionate about bringing better, cleaner, and more cost-effective energy for homes. And I've spent the last 15, 16 years of my life really working to do that. I also love the outdoors. I am an avid gardener. In fact, here you can see me combining a couple of my hobbies, right? Science plus gardening. This is a test garden in the UK where they're testing out thousands of varieties of new flowers. So it was paradise for me. All right, let's jump in. Let's start with the problem. What caught my attention first was the fact that heating and hot water are responsible for a massive 2/3 of US home energy use. Most of that is from burning gas or fuel oil in our boilers, furnaces, and water heaters. So that's a tremendous opportunity. Just 2 appliances use 2/3 of the energy in your home. So making sure we choose the right solution and approach is going to be really impactful. And that's what Harvest is about. Even more so when we realize that home heating and hot water, just those 2 things, are responsible for a massive 10% of climate emissions. So it's definitely a challenge worth tackling. Now, heat pumps are clearly a critical part of this solution. So let's take a look at, first of all, what a standard heat pump solution looks like, and then we'll build and see where Combi systems can fit in. So a regular heat pump system, and I know Brian's already shared much of this, but it's going to look something like this. You're going to have a heat pump for space conditioning and a heat pump for hot water. This can be an integrated system as shown here, or a split system with a compressor outdoors and a tank indoors. If you have that integrated system, be very careful, of course, where you place the unit. It's going to be generating cool air and maybe generating a little bit of noise. So you want to make sure that the compressor is in your basement, is in your garage, or in some unconditioned space. Now, both these devices are fantastic. They're, of course, moving heat rather than generating it. So they're many times more efficient than even the best gas furnace. And they're a great way to heat your home. But these systems do have some drawbacks, which impact both the costs that you're going to incur as a ratepayer and also the broader scalability and impact on the grid. And that's what I want to start by looking at. So let's imagine that you are now a grid operator. You're responsible for delivering electricity to tens of millions of homes safely, reliably, and affordably. And your day may look a bit like this. So this is between midnight and midnight, the emissions and costs of generating electricity. You've got higher costs in the morning and the evening. You're having to ramp up peaker plants. You've got lots of lovely, clean, cheap solar in the middle of the day. In fact, sometimes you have to curtail it because people are not using it enough. So this is what people call the duck curve. Now, so we're talking about 2/3 of the energy used at the home, which is primarily using gas today, and that needs to transition to electric systems. What are the challenges with that? Well, one of them is that those conventional heat pumps operate instantaneously. And when do we need heating? We need it in the morning and the evening. So they are adding load to the grid, driving the need for costly capacity upgrades, which at the end of the day are going to be borne by us, the ratepayers. In addition, if you're running the heat pump like this, what's happening? Well, you're running it at 1 a.m., you're running it at 5 a.m. Heat pumps are very temperature sensitive. They're going to be a lot less efficient, if you're running it when it's cold than if you can run it when it's warm. And if you happen to have solar panels on your roof, this doesn't really allow you to self-consume very much. And we're talking about a huge load, right? 2/3 of the energy used to the home. So it would be good if you'd be able to self-consume your solar electricity for that purpose. Now, wouldn't it be nice if the heat pump usage could look like this? And that's what Harvest does. Using the heat pump in the middle of the day, using thermal storage, and then delivering the heat and hot water whenever you need it. And as one of my customers said, basically turning that duck upside down. All right, so let's take a look at how we do this. And I'm going to start a short video, and then I'm going to dig into more detail. Let me know if this is
Hi, I'm Jane. When my gas furnace died a few years ago, I knew I wanted to build something better, without using dirty, expensive fossil fuels. So we built Harvest in our basement. Harvest combines heating and hot water in one all-electric, super-efficient system. Unlike a gas furnace, Harvest knows what time it is. Most people use hot water and heat in the morning and at night. Our heat pump takes energy off the grid in the middle of the day, when there's a lot of cheap, clean solar power. Clever. It stores that energy in a hot water tank. Throw our smart pod in the mix, and we call that a smart thermal battery. Harvest takes that heat into your home smartly, all before you have time to say it's chilly in here, because you won't be. What's it boil down to? Plenty of hot water, a crazy comfy home, 30% lower energy costs, 90% fewer emissions. Yeah, 90%. It's time. Time to heat your home, not your home planet. Hi, I'm Jane.
Right, try and move forward. Thank you. Okay, so let's summarize. What is Harvest? So essentially, it's combining heating, cooling, and hot water with thermal energy storage in the form of a water tank, a standard hot water tank. And that thermal energy storage makes both heating and hot water demand flexible, moving it to whenever electricity is going to be cleanest and cheapest, and fully decoupling heat pump operation from heat and hot water delivery. The system is streamlined. Like as a Combi system, we're using one single heat pump for the heating and hot water. We're using the tank as a battery. That allows us to reduce first costs and, of course, those operating costs. So what does the system look like? So a system is going to be made up of these devices. You can see a split heat pump water heater with the compressor outdoors and the tank in your tank closet or a corner of your garage or in your basement. Then there's the Harvest Pod controller, which is about the size of a large shoebox. And then the distribution, well, hot water is conventional hot water. And then the distribution can be standard forced air if you already have forced air in your homes, or radiant floors. And we're now beginning to work with radiant baseboards and radiators as well. So what's happening here? Well, first of all, what's the pod doing? So the pod is understanding how much heat will your household need in the next 24 hours, based on your prior behavior, based on how your home responds, based also on the weather forecast. Once it knows how much heat you're going to need for both heating and hot water and when you're going to need it, it's able to plan ahead. It's able to run that heat pump water heater to generate that amount of heat, plus a little extra for buffer, while maximizing efficiency and minimizing the cost to you, the ratepayer. That heat's going to be stored as hot water in a tank and then delivered through a hydronic air handler or radiant floors to your home. That tank is the battery. It's essentially, we're using a stratified tank, hot water floats, so you get hot water at the top, cold water at the bottom. That means it's very modular. In the winter, we may heat the whole heat twice and have about the same energy capacity as, say, a conventional Tesla Powerwall or other lithium-ion battery. But in the spring and summer, we may only heat half of it. And in summer, maybe just a quarter. So very modular, so you're not wasting any energy. And basically, fully decoupling heat pump operation from heating delivery to allow you to maximize efficiency and minimize your bills. Now, the question always comes up, what about cooling? Well, this heat pump water heater that we use is only heating the water, but it works seamlessly with either an existing AC. If you already have AC in your house, we can work with that, or you can install a separate AC unit, and the pod will manage all of that. So what does that deliver? Well, as the video showed, we're cutting bills by about 30% compared to gas, compared to regular heat pumps. And we're also cutting those emissions by about 90%. In fact, each harvest system avoids a release of about 75 tons of CO2 over its lifetime. Now, that's a bigger saving than if you were to swap out your gasoline car and replace it with an electric vehicle. It's probably the biggest single thing you can do to reduce your carbon footprint, all while saving on bills. Probably the most important slide here is that we have very high customer satisfaction, which means a very strong customer experience. In fact, we've got a customer net promoter score of close to 90%. That is the response to the question, would you recommend this system to your friend, your family, your neighbor? The average in the industry is about 40%. So this is something we're super proud of. What that means is it works well. It delivers quiet, stable heat, meets all your heating and hot water needs. And as well as customers like it, it works well for the contractors who are installing our system in California, the Northwest, as well as in Colorado. We provide them with a lot of support, a lot of documentation and training, and monitoring and alerts to make their lives easier. Now, I'm going to geek out just a little bit to give folks the why and the how. How is this system able to save on emissions? How is it able to save on bills? So I mentioned a couple of times that heat pumps are temperature sensitive. And this chart is really trying to illustrate that. Horizontally, you can see this is the outdoor temperature. And the red line is showing how the performance or the efficiency of the heat pump varies with the outdoor temperature. So if you can choose to run your heat pump at noon rather than running it at 5 a.m. or at 1 a.m., you can gain about a point of COP. You can gain substantially in terms of performance. And that's why harvest systems in the field have performance of 3 or 3.1 COP, 310%, which is a really strong performance, enabled by this temperature arbitrage that we're able to do. Similarly, what about the rate schedules? So many of us here in California are on time of use rates. And I know that a lot of places in the United States do offer time of use rates. And it's something that we're expected to see grow over the years as utilities and grid operators grapple with that expensive electricity in the evening and try and share the burden and allow people to move away from using that electricity. So what happens in winter using a heat pump system? Well, conventionally, you have to be using electricity at these times because that's when you need your heating. Not so with harvest. This combined system with thermal storage allows us to completely decouple heat pump operation from heat and hot water delivery. That means even during the winter, the harvest system is really minimizing how much expensive on-peak or mid-peak electricity we're using. So people's bills stay modest. They reduced, which is a big advantage compared to conventional heat pump systems. So where does harvest work? Well, as I mentioned, we've been focused primarily where I started here in California, where we've got a large number of contractors trained, so up and down the whole of California. We're also available in the Pacific Northwest and Colorado, and we'll be expanding our geographic reach in the coming months. The system works for a range of homes. The Harvest Classic works for homes who don't want or don't need cooling, particularly on the coast. Harvest Open is interoperable. It can integrate with pretty much any AC unit. So if you've got AC or want to add AC, we can work with you. Then Harvest Radiant, as the name implies, this is for those of you who have or want radiant floors, and we can work with them as well. So we started in the retrofit space, and we've deployed nearly 300 units in single-family retrofits. And we've also done new homes. Here's a property in the Central Valley in California that we've done with KB Home. And this is a typical layout you're going to see: the heat pump outdoors, the tank in a garage, or your basement, or your tank closet. The pod is usually a bit quite close to the tank, and then a forced air distribution, this space delivering the heating to the home. And in this case, they added cooling as well. And what I'm really excited about is announcing that Harvest now works in multifamily. And we've deployed our first couple of multifamily projects. And this is expanding this technology, not just to single family homes, but to multifamily homes, market rate, as well as low income. So I'd like to share a little bit more about what that looks like. Bear with me.
My name is Ruthie Levin. I am a sustainable housing project manager for Eden Housing. We serve 22,000 people in California. Eden Palms has 145 units. We see the Harvest Pod as an opportunity to lower our residents' energy bills. We hope our residents will save 20% on their heating and hot water costs.
Harvest uses thermal energy storage with a heat pump to make that heat pump flexible and be able to shift the operation from times of high price and high emissions electricity to times of low price and low emissions electricity. And that can save 20 to 30% on heating and hot water costs. We had to develop new documentation to help maintenance staff as well as help residents separately from what we do in single family.
We have a big lofty goal of reducing our GHG emissions by 50% within the next 10 years. I'm counting on Harvest to deliver a product that helps our residents save energy and will prove to our entire organization that this is a way to go forward.
To learn more about Harvest for Multifamily, go to harvest.green/multifamily.
Okay. All right, so I wanted to end with some photos to show folks what this actually looks like. So here you can see a Harvest system installed in a tank closet. So basically the tank, which is nicely wrapped to minimize thermal losses, and the pod just beside it. Here you can see a similar system. This is in the corner of a garage. In this case, you can see that the plumbing's been nicely insulated, always making sure you minimize those thermal losses, because this is a heat battery. So you want to make sure you keep that precious heat. Here you can see it in a basement, and here you can see both the tank and the pod, and next to it is the air handler distributing that warm air inside the home. Now, most of our homes have been central air. We've done a number of radiant floors as well, which works well. And most recently, we're now expanding into baseboards, radiators, and hydronic splits. So this is new. So it's going to be emerging over the coming months. But these are basically fan-assisted devices that allow us to expand to different form factors depending on the need of different homes. And that's really what I wanted to share today. So I look forward to the ongoing discussion and questions. Thank you.
Thanks, Jane.
Great.
Appreciate
Thank
it.
you, Jane.
Lots of great questions coming in. So folks, just a reminder, please put your questions in the Q&A. We'll try to get to as many as possible.
So maybe can we start with the water tank? Well, I got a lot of questions for you, Jane, and I know that our audience does too. But that was really helpful. Thank you. So on the water tank, are we talking about a tank that's pretty much the same size as a conventional water heater? You know, like I think the average size for most homes is 50 gallons. Maybe you'll see a 80-gallon tank occasionally. Is it larger? And also, do you drive to hotter temperatures inside than a typical hot water heater?
Excellent question. So we are using a tank which is a little bit larger than you typically see for conventional just hot water, because we're delivering your hot water and your heating. So most homes employing our system have got a 119-gallon tank, which is 28 inches diameter, 5 foot tall. And it actually fits into most tank closets, the corner of the garage, the basement. Because it is a split system, it doesn't have the compressor on top. So we're finding that it fits into most places because you don't have that added, electronics and compressor on the actual tank. And so that means it does fit into most places. But really important topic about the temperature. So what Harvest is doing is using a heat pump that heats to higher temperatures, 150 degrees. And what that means is we've got a lot of good energy density. Most heat pump water heaters are going to be heating to 120 degrees. So if you want to shower at 115, you're basically using that water directly without any dilution. The fact that we've got the water stored at 145 to 150 degrees means that we're mixing it down with utility water, basically doubling the energy, the volume of hot water available to the home. And that's one of our secret sources. Having a good energy density in a moderately sized tank means we can deliver all your hot water needs. We can shift the heating load by several hours to off-peak times with a tank that's going to meet the needs of many, many homes.
Gotcha.
Jane, we've gotten a lot of questions here about folks with some existing system, whether it's heat pumps and an electric water heater tank, or tell us, can Harvest work at all with existing heat pump systems, or do you really need to buy the entire package and get it designed by Harvest?
Yeah, so most of our customers are coming to us when it's time to replace their gas furnace, and we're going to swap out your furnace and your water heater and do them at the same time. Now, if you happen to have the Sanko 2 water heater, which is the water heater that we're working with right now, that's happened in the past. We can work with that, but otherwise you're going to be adding this heat pump water heater as well as the Harvest pod. We do reuse your duct system. Obviously, you want to check, make sure it's of good quality, make sure that aren't any leaks, but we typically don't disrupt the inside of your home. We can use existing forced air, we can use existing radiant floors, but for the engine, right, basically the heating part, you're going to want to use the Sanko 2 heat pump, which is the company we've partnered with.
So a couple of questions there. On the radiant floor systems, my understanding, and maybe your system is different, but when I've poked into this before about whether, because we get this question a lot, like, if you have a radiant floor system with a gas boiler, could you replace your gas boiler with a heat pump? And what I tend to hear from the people who make air to water heat pumps is that that's a hard thing to do, because typically if you can definitely do radiant floor heating with a heat pump, but in general the actual radiant floor is designed differently. It has a higher density of my understanding, a higher density of water pipes, because the water is typically being delivered at a lower temperature than a gas-fired boiler would deliver. So you have to have more surface area of your pipes in order to get the same kind of heating. But it sounds like you're experiencing the ability to retrofit existing radiant floor systems with your system.
We are, and we have done that, but the devil is in the details, right? It does depend on the specifics of the radiant floor that you have. Okay. Is it properly insulated? How thick is that cement slab? Because in some cases, some of the older ICLAs, the pipes are deeply buried into concrete, and it's going to be, it just takes a lot of heating load to be able to overcome that. That works well with the roar of a gas furnace, but it's not well suited to heat pumps. But in many cases, it does work. It's a question of having a look, seeing what you've got, and trying to work with that.
Gotcha.
Great. The cooling is a big question folks had, and I know you touched on that in your presentation. Some of the other models and companies that Brian mentioned, some do have space cooling as part of their units. Talk to us about how folks kind of make that decision to go with Harvest and then do a separate cooling system. And I guess maybe a question is, what were the hurdles to adding cooling to the Harvest system?
Yeah, so I mean, the primary mission of Harvest is helping homes transition from that gas heating, the gas water, and do so in a way which is going to be cost effective, it's going to be grid friendly, it's going to be scalable. And that's really what the Harvest system does. There is a growing number of air-to-water heat pumps which are coming to the US, which is very exciting, that also have the ability to do cooling as well. So what our customers do right now is if they already have cooling, they can typically keep it. If they don't already have cooling, we can add it. And it's always that trade-off. A Harvest system is future-proof because we've got a thermal battery. We're always going to be able to do arbitrage and save your bills about 30% month over month, year over year, and be protected against hikes in those rates. And so that is while cutting emissions more than a conventional system because we're able to use the clean solar in the middle of the day. But it's a question of having that separate compressor outdoors to allow you to get that cooling. And that's a question that we work through with our customers and contractors to figure out what's best for them.
Yeah, just following up on that, because I had a similar question. In this sort of two parts, but most of the suppliers, like those brands that I mentioned on the brand screen, most of those suppliers are developing or delivering complete kind of turnkey systems where every piece of the system is something that they're delivering with their brand on it, et cetera. And Harvest doesn't use that strategy. From what I understand, you work with third-party suppliers of the other components, and your piece of it is the Harvest pod, the controller, the smarts, the brains of the system is from Harvest, and the rest of it comes from other suppliers. So I guess I'm sorry this is going to be a complicated question, but I'm curious why you did that, first of all. And also, is back to this question of air conditioning, is the reason that your system can't supply air conditioning with the same external heat pump, is that basically because of suppliers that you're working with, and at some point if some other supplier comes along with a air to water system that can do both heating and cooling, you could incorporate that into your Harvest system, but that isn't available now? Is that, I don't know, is that too complicated of a question?
Sorry, there's a lot to unpack there.
Yeah.
So we're using a CO2 heat pump. The Senko 2 is a high performance heat pump that uses CO2 as its refrigerant. CO2 is, of course, the lowest GWP refrigerant on the market, with a global warming potential of 1 compared to our R410A, which is around about 2000, and even R32, which is around about 680. So in terms of the risks, if that refrigerant is leaked, the CO2 is a really awesome product to go with. The flip side of that is it does not do the cooling part of it. And that's why we partner with third parties for the AC, and we integrate that. And
sorry, just on that factor, is that a function of the CO2 refrigerant that makes it not possible to do the cooling, or is it?
Yeah, the CO2 refrigerant, it's basically the efficiency works very well in the heating cycle and not in the cooling cycle. And that's about as far as I can go with that before I have to get my engineers on.
That's deep enough.
But yeah, what that means is it's actually challenging for it to do cooling. So the Senko 2, for example, only does heating. Now, you touched on something important, which is what Harvest does is takes third-party heat pumps and makes them better, right? Adding this capability of managing the state of charge of the thermal battery and all the fluid mechanics associated with that, and doing the predictive demand so that we can make use of that to load shift, not just your hot water, but your full heating load. So our job is to take third-party heat pumps and make them better. And we absolutely love working with the Senko 2. Now, it's very exciting to see that there are new and more other heat pumps arriving in the US market that have additional capabilities. And it's certainly something that I'm interested in looking into for the future.
Great. Yeah, maybe, sorry, let me keep going on that topic, because while we're talking about refrigerants, I had mentioned that propane is a potential. I know I don't think it's currently legal in the US, but it's being offered in Europe. And I know the ASHRAE is looking at a standard for that, and the DOE is. So it sounds like there's some potential that monoblock systems would be able to use propane in the future. But do you have any comment on that or knowledge about that?
Yeah, I think there's a lot of a lot of innovation happening in this space right now. R290 has worked very well and very safely in Europe for a number of years. And I see a lot of opportunity to see how we can make that happen also in the United States, because it has a lot of benefits in terms of being a natural refrigerant with low carbon impact. Heat pumps with the monoblock, where the refrigerant is contained in the block and doesn't run through a refrigerant line into the house, have more limited safety impacts than if you're having to run refrigerant lines. So we'll have to see what happens. The appropriate bodies are looking into this carefully, but I am hopeful that we'll start to see some movement in the US in the coming months on this front.
Thank you.
I'm going to try to combine two questions because there's so many great ones coming in. So some folks are asking about cold climates and how harvest works in cold climates, and then other folks are asking, are there situations when folks need multiple tanks, and maybe that's part of like cold climates? Do you ever need to stack tanks together?
Yeah, so the Senko 2 is a cold climate heat pump. It delivers the same capacity down to 5 degrees Fahrenheit and actually operates below that, but at reduced capacity. So this is already a cold climate system. In fact, we've actually deployed a couple of systems up in Edmonton, Alberta, which is about as cold as you get. And we've also deployed systems up in Truckee in the Sierra Nevada as well. Now, all heat pumps lose some efficiency as temperature goes down. And the harvest system is also something that we have to be very vigilant about. But a harvest system has a built-in advantage in that we don't have to run the heat pump at 1 a.m. or at 5 a.m. Because we are load shifting, we always get that temperature advantage of being able to run it in the middle of the day. So if you're in a cold climate and you want to put in a heat pump, a harvest system is typically a better option because you've got that load shifting capability. Now, the system,
it's like in the colder the climate, the more that
the more that the more that makes a difference, I think Brian was saying.
It does. And also the harvest system is modular, right? The harvest system works very well by itself. But if you're in a colder climate, we can integrate it with, say, an electric resistance booster.
offers you what we've seen. Yeah.
Can you hear me? Sorry.
Yeah, we can hear you fine, Brian.
Yes, we lost
Okay.
you.
Yeah, I think you cut out Brian just for a second.
The system is modular. So, for example, if you have a separate AC unit for cooling, that can deliver supplemental heat. We can, in a very cold climate, combine it with a gas furnace. The harvest pod will operate 90 to 95% of the time, but on the very cold days, you can use that hybrid system for gas, or similarly, an electric resistance booster at the exit of the tank, not in the tank itself, but just giving a top up on those coldest days if you're in a cold climate. So really trying to make it as flexible as possible so it can work in most homes, really whatever the climate is.
And the 2 tanks or the multiple tanks?
So that's a question of how much load shifting you're going to deliver. So you can think about it this way. So the heat pump is the engine deciding how much heat you can deliver. And in some larger homes, such as people sometimes put in 2 gas furnaces, we've had folks that put in 2 Senko 2s, right? And that is the engine generating how much heat. And the tank is your battery and is determining how much you can shift that load. And so we've had customers say in some larger homes in the East Bay, and what they have space, so they're putting in a second tank, and that allows them to shift the load, so further reduce the bills and further reduce their climate footprint. The majority of homes, though, just have 1 tank, which is that 119-gallon tank.
Okay.
We have a lot of questions on the thermal storage in terms of trying to equate this to like battery storage, which people are pretty familiar with. Oftentimes come in a kind of 10K increments. Kilowatt hours. So how do you think of that in terms of what a tank can deliver?
Yeah. So first of all, a lot of the lithium-ion batteries are really used for resilience and not so much for load shifting.
Yeah.
And charging and decharging that battery, if you want to do it for resilience, has an impact on its performance, right? It does degrade over time. So I see electrochemical batteries are great for that resiliency and for maybe supporting electric loads. But for thermal batteries, a hot water tank is going to be much more durable. It's safe. It doesn't degrade over time. In winter, we're able to load and use up that tank twice over the course of 24 hours. And that is shifting about 11 to 12 kilowatt hours of energy. And so that's where you get it very comparable to that unit of a lithium-ion battery that we're seeing. So that's the amount of load that we're able to shift. But the key thing is we're actually shifting that day in, day out without any degradation. So I'd say keep your lithium-ion battery for your electric load, but for thermal loads, a hot water tank is an awesome way to go.
Great, that's fascinating.
Great.
11 hours.
So just maybe on the battery, the thermal battery thing, one of the things that I've, in my research, what I realized is that, any supplier of a Combi system has a water tank as a really important part of the operation of the system. And because that's kind of this buffer, they often talk about it as a buffer, where you're using it, where you can either use it for domestic hot water, for heating, etc. But I have not seen in the literature from any other brand a discussion about using that thermal, that water tank as a thermal battery. You're the only brand that I see talking about that. I'm curious why you think that is, because it seems like this is one of the potentially the biggest advantages of a Combi system, is that load shifting capability. And yet none of the other brands seem to be talking about that advantage.
Yeah, I mean, a lot of people say when they see what they're doing, the light bulb goes off and it says, wow, this is obvious. Of course, this makes sense. You can do it. Use that tank, store it, and deliver it later on. I think the challenge is that it's actually harder to do than to say. And so there is a fair amount of complexity in particularly managing the state of charge of that battery. And so right now, Harvest is unique in being able to shift both your heating and hot water, and being able to shift 90% of your heating load to whatever time of day makes the most sense. But the other companies are not yet doing that. What you'll find is that buffer tanks are relatively small, and they're typically not storing at these high temperatures, which means that the energy content in that buffer tank may be a quarter or a fifth of what Harvest will have. And it does depend a little bit on the manufacturers. So there's a couple of things. One is the size of the tank, which is of course easy to overcome. The other is the capability to really manage the state of charge of that tank. And that knowledge is key to the actual operation of the overall system. So we're the first movers in this space. It has significant advantages in terms of bill reduction, efficiency of the heat pump, grid scalability and use of renewables on the grid. So I expect and look forward to seeing many more folks doing something similar, because I firmly believe that in 5-10 years, this is going to be a normal part of an HVAC system. Heat pump, thermal storage gives us all that flexibility and allows us to electrify homes without the negative grid impact.
And isn't it true? I mean, we haven't talked a lot about costs yet. Maybe this is a good segue into that, but because we've got a lot of questions there, but that is also potentially a way to reduce first costs also, isn't it? By having the thermal battery capability. Is that true? I mean,
yeah, I mean, clearly we're so much more than just a heat pump system, because we have the thermal battery capability as well, which most heat pumps don't have. So you have that added functionality, which allows you to self-consume renewables, your solar, for example, which has, saves you money, which allows you to reduce your bills, increase the efficiency of the system. So there's so much there that is built into what Harvest does that is above and beyond what is seen with the conventional heat pump system. So that's really important. In terms of, first cost, right now we're still a small company. So what we're seeing is with eligible incentives, people are paying about the same for a Harvest system than they would for a conventional heat pump system, while getting those bill reductions. And then of course, over time, we scale up, we continue to streamline the installation process, streamline our partnerships, and work to get those costs down even further.
And I seem to remember hearing that your systems qualify for battery storage incentives. Is that true because of the thermal battery functionality?
Correct. Yeah. I mean, it's all about the tax code, right? There's something called Section 48 of the tax code, which has a thermal battery a system that's for third-party owners, such as rental property owners. So that's a 30% tax credit. There's also Section 25D, which is the one which is used by solar, which is a 30% tax credit, for example, on a solar system, but also on a harvest system. Okay. So this really is designed to really support the expansion of technologies that really reduce our bills and make it more cost effective to electrify and make it better for our grid. So yeah, our customers can benefit from those, and that's really impactful. So
just to put a fine point on that. So it sounds like what you're saying is that with the incentives that are available, including those ones around thermal storage, that the first cost can be comparable to a heat pump plus heat pump water heater system. Is that what you're saying?
Yeah, absolutely. And depending on where you are, because there are different incentives depending on your zip code. So, in some cases we find that we're actually significantly cheaper, but in many cases we're comparable to a regular heat pump system.
Great. That's super helpful on the cost. Yeah, that 30% tax credit's huge. Yeah. So a lot of folks are asking about contractors, and I know this has been a challenge for Combi systems in the past, that finding the right contractor. So how do you recommend, you talked a little bit about this in your presentation, but how do you recommend folks get started? How do they find a contractor that could install Harvest or potentially another Combi system? What's the best way?
Yeah. So for Harvest, the best way is on our website. There is a button that says Get Harvest, and click there, and we'll work with you, understand where your zip code is, and put you in touch with a trained contractor in your zip code. That is if you're in California, the Pacific Northwest, or the Denver area. That's where we have trained contractors right now who've deployed many systems and are ready to come and have a look at your home and see what's needed and give you a quote. So that's the best way to get Harvest. You can also reach out directly to contractors, but the question is, do they know us already or not? So the quickest way is just to go through us, and we can do that pairing. Now for other, if you're outside of those areas, or obviously we're looking to expand, but we're far from being everywhere. But if you want to put in a Combi system, say you're in Minnesota, for example, I think the best approach is probably to reach out to one of those manufacturers that you'd shared on your slide earlier, and understand, do they have contractors in your zip code, and see if they can help you out with that in places where Harvest is not yet present.
Right. Well, so in the areas that where Harvest isn't present and you can't easily find them, we would say that this is more of a nascent technology. It might be a little harder to find a contractor than your typical air source heat pump HVAC folks.
Yes.
Hopefully this is changing, but
at the moment, and I think if you look at Europe, you see the percentages are pretty much flipped. Oh, wow. And so there's I think we're going to see this change significantly in the coming years as we try and move to lower GWP refrigerants, which tend to be more the split systems, and for which the air to water heat pumps are really well suited.
Yeah, I mean, it would seem like in the Northeast, where there's a lot of water-based heating systems, they're the old fossil fuel-based versions of those, but there's a lot of already water-based systems in the Northeast. You would think that would make these systems like more obvious. Do you think that's true, or is that?
No, I think there's a plenty of opportunity in the Northeast in many places. I mean, we are actually in early discussion with some partners up in Vermont, up in Massachusetts, and so on, and look forward to expanding there in due course. Yeah, there's not a limitation regarding opportunity. It's a question of, let's get there as quickly as possible and help homes when that time comes to replace your gas boiler or your fuel oil boiler, making sure that it was a good heat pump solution for you to put in. Because what we don't want is for you to replace that gas furnace or fuel oil boiler by another fossil fuel device. So, wherever you are, when you've got that decision, look for a heat pump solution, because that's going to be cleaner, be more efficient, and be a good electric solution for 15, 20 years to come.
Absolutely. I have a question for you about split versus monoblock. I think I think we've discussed some of the advantages of monoblock from a refrigerant standpoint, but do you see any, there's definitely differences in terms of the size of these units. I don't know if there's a difference in terms of noise, but that may be a question, but what's your take on monoblock versus split, and what the advantages and disadvantages might be?
For the water heater?
Well, just in general, I think your system now is a is a split system, correct?
Yeah.
That but I mean, if like down the road, if there's a really good monoblock system that comes available and you want to integrate in your system, why would you choose a split versus a monoblock?
So, well, we like the split because having the heat pump out, we have the heat pump outdoors rather than having it inside, because we're not just generating hot water with that device, we're generating also all your heating. And so you don't want it inside the home if it's going to be releasing.
No, I meant monoblock,
yeah.
like basically, so the monoblock system is outside and all the refrigerant's outside and it's got water lines in, versus a split system where you're putting refrigerant into the house. That's what I was.
Oh yeah, so yeah, absolutely. I mean, running those refrigerant lines it requires certain skills, and it's also, we're seeing many customers would prefer just to have a water line running into the house than having a refrigerant line running into the house. At the end of the day, a system which is factory sealed with the refrigerant in it is going to have much lower risk of releasing that refrigerant into the atmosphere.
Right.
And so that is in my mind, a safer way to contain the refrigerant and its global warming impact. So
I see.
Yeah,
So
maybe
so it sounds like your system is a monoblock system.
It is.
Okay, sorry.
Yeah.
Okay, great. Thank you. I understand. It sounds like you're a fan of monoblock then.
Absolutely, yes.
Okay,
yeah.
gotcha. Thank you.
A couple folks were asking about the electrical service that you'll need for a Combi heat pump. Are there savings on the size of circuit you need? Or are they going to do they need a bigger circuit? How does the electrical infrastructure look?
So the Senko 2 that we use, it requires a 15 amp circuit. So it's actually pretty low in terms of capacity. Most panels can accommodate it. If you want cooling with that, if you've already got cooling, you're already set. If you want to add cooling, that's going to be maybe 30 amps, maybe 45 amps on top of that. I think the key thing here is, because we are decoupling heat pump operation from heat and hot water delivery, the peak load needed by that heat pump is actually less, because that peak load is delivered from the storage device, not directly from the heat pump device, which is why we can have a pretty low, amperage requirement for the panel. So that's for Harvest. Now for the other heat pumps, there's a range depending on the size and the capacity of the device.
I would think in California, where you got a lot of small panels, I mean, from what I understand, in California, this panel size thing is a pretty important consideration.
It is.
And that there's a lot of homes that are in that place where it's tricky to electrify with all the various loads, including vehicle transportation. So
it can be a big cost saver if you don't have to upgrade your panel.
Yeah.
So that's something that a lot of our customers appreciate. It's a 15 amp that can help them make their decision. They don't have to upgrade the panel. That's a big deal.
Yeah, that's great. That's great. Well, good. How are we doing, Joe? I know we're getting close to time here. We're getting close to the hour.
Yeah, Jen, maybe one potential final question is, where do you see Harvest going and the industry going? You said a little bit of that. Do you think we'll be seeing a lot more Combi heat pumps in the near future?
I think so. I mean, particularly as new refrigerants come to the market, air-to-water heat pumps are really well suited to that. And we're beginning to see more air-to-water heat pumps come to the US. So I'm expecting to see that. And of course, the beauty of the air-to-water heat pump is, as opposed to an air-to-air heat pump, because it's storing heat in the water, it opens the door to the type of thermal storage and load shifting that Harvest does. So if you go to some of the industry conferences like AHR, you see a lot of the manufacturers sharing the air-to-water heat pumps that they're bringing to the US. So I expect to see a lot of change in the next year or so as these start to come to market. And what that means is the ability for more people to benefit from load shifting, and for us to electrify homes without burdening the grid, allowing us to use up the renewable electricity. So as I mentioned earlier, I would expect within 5-10 years, thermal storage to be a normal part of a heating system because it gives us so much flexibility and it can save money.
Fantastic. Yeah, well, thanks for
great.
that.
Yeah.
Well, thank you. Thanks, Jane. Thanks for being on. We got to a lot of questions. There's still a lot more. We'll try to capture the ones that we didn't get and circle back with folks. But yeah, really appreciate you coming and talking to us about Combi heat pumps and Harvest's really innovative product.
Thank you. Thank you very much. Bye-bye.
Thanks. And thanks to everyone who's tuned in today. And if you have questions that we can help you answer, please feel free to reach out. We'll try to put you in contact with someone who can answer any electrification question you might have. So thanks for joining today, and hope to see you at one of our upcoming webinars in the future.
And good luck on your electrification projects. We'll see you at the next one.